This is section 4.6, isosceles and equilateral triangles. Let's spell that correctly. So some terminology here. With our equilateral and isosceles triangles, we have legs on our triangles, and these are the congruent sides. So in this triangle here, these two sides are our legs. They are congruent. Then we have what's called a vertex angle, and right up here, this angle 1 would be our vertex angle. So we'll put angle 1 there. Our base angle then, those are the two angles formed by the base and the legs. This side here is our base. So these two are our base angles, number 2 and number 3. So this is angles 2 and 3. The isosceles triangle theorems, we have two of them to look at. The first is just the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So we have the two sides, and the sides opposite those two sides are A and B, and those two triangles are congruent. The second theorem here is the converse of the isosceles triangle theorem. And this states that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So here we have our congruent angles. So the sides opposite them, the side opposite F and the side opposite angle D are congruent, and we have an isosceles triangle. Looking at example 1 here, we have these two triangles side by side. And what it wants us to find here are the angles that are unmarked and congruent and the sides that are unmarked and congruent. So we have angles C and D, which are congruent. And since they are congruent, we know that side BC is congruent to side BD. And then as far as the angles, I got a little bit ahead of myself, but since BC and BA are congruent, therefore our angle BCA and our angle BAC are congruent. And I marked those in already, but we had a figure that did not have those little marks in there, but we knew sides BC and BA were congruent. So at this time, I want you to pause your video and complete Check Your Progress 1A and 1B. Continuing on in section 6, we have corollaries to look at first of all. Corollaries are statements that can be easily proven using a theorem. So corollary 4.3 states that a triangle is equilateral if and only if it is equiangular. So here in triangle ABC, we have an equiangular triangle. Therefore, because of the corollary, we can say that it is also equilateral. With corollary 4.4, this one states that each angle of an equilateral triangle measures 60 degrees. So we have an equilateral triangle. All the sides are the same. So we know each of these angles measures 60 degrees. Now moving on to example 2, finding the missing measures. We have triangle PQR. We're given that two of its sides are 5 centimeters and that the included angle is 60 degrees. It's asking us to find the measure of angle R and the measure of PR. Since we have our two sides here that are congruent, we know that these opposite sides are also congruent. And by way of knowing that all three angles in a triangle add up to 180 degrees, if we take 180 and we subtract off 60, we're left with 120, and that is the measure of two congruent angles, so we can divide by 2, and there we have that the measure of angle R is 60 degrees. We also know now that we have 3 60-degree angles, so it is an equiangular triangle. And then going back to here, since it is equiangular, we know that this measure of PR is 5 centimeters. I'd like you to pause the video and complete check your progress 2A and 2B. We have here example 3 where we're going to be finding the missing values of x and y. Here's our triangle DEF. They have segment DF as being 6 plus 3 and segment FE as being 8y minus 5. So we need to find the y values for these. And then they give us that angles E and angle F, they are both equal to 4x minus 8, each of them individually. I guess first of all, I'd start off with finding y. Since these are congruent sides, we can set them equal to each other. So we have 6y plus 3 equal to 8y minus 5. I'm going to move the 3 over to the right side, so subtract 3 from each side. I'm going to move the 8 over to the left side, so subtract 8 from each side. And this leaves us with negative 2y on the left side, and these cancel off here. We have negative 8 on the right side. Divide through by negative 2. And we have y equal to 4. With our angles E and F here, we know that these are